Good morning, good evening, good afternoon. Hope everyone is well. Apologize for being a couple minutes late here. Dance, you have a link, sir. And I'll hold up just a second to let Dance join up. I got caught in the wonderful comet, so we'll discuss that as well in just a moment. What's up, buddy?
Hey, nice to meet you. Oh, sorry, my brain's melting. Hi, nice to see you. I was gonna say nice to meet you. I've obviously met you before.
Nice
Um,
to meet you as well.
yeah, nice to meet you. Hi. Yeah, it was just because I was trying to mute the other window, so I didn't get the sound coming back again.
Gotcha.
But yeah, thanks for having me on. I was looking forward to this one, thermodynamics. Yeah,
Yeah,
I think this. I'm not going to jump ahead, but there's going to be some stuff in here that is going to, I think, strengthen both of our positions and our different opinions on the universe. So.
yeah, it's an interesting one. So definitely.
Uh, And just before we get into stuff, if I share screen, this one, I meant to show you before, but I couldn't remember if it was you or Val that was like that was into hockey.
Yeah,
Was it you or Val or both?
I played college hockey, so yeah.
Yeah, like I know it's not very big in the UK, but I used to play like a little bit of roller hockey as well here, so that's actually me. I mean, I wasn't very good. I was pretty useless. But and then the other one for any Doctor Who fans out there, this was like a prop that I made for it was like a play, like a local small play, and they needed a the police box sort of prop. So, but that's good for memes. So you can screen grab that, and then like one of them was like, I've just come back from the year 2031, and they're still counting votes in Arizona. So feel free to screen grab that and make whatever memes you want. Um, anyway, sorry. I'll how do I stop that then? Stop screen. There we go.
Yeeted immediately. Already making fun of Arizona.
Yeah, well,
Um,
I mean, the one I did about it was about Brexit, but that won't mean as much to the Americans. But yeah, I forget what I said about it now. Because it took about 4 or 5 years for them to actually do it. The politicians were arguing about it for ages and trying to sort of not do what the public had voted for. So I think my meme was something like, "I've just come back from the year whatever it is, 2050 or whatever, and they're still trying to figure out the deal."
yeah, that was a mess too. Like, yeah, we want to leave, and then they're like,
All the
we don't.
politicians were like, nah. Do you know what was hilarious for me though was because you got like the BBC, the British Broadcasting thingy, and they're very kind of leaning, left wing kind of thing and stuff, and they were all very pro stay Europe, and that's what they thought the vote was going to be. So
Mm.
when I woke up the next morning and they counted the votes, and it was the news people, the reporters, they were looked like rabbits in the headlights. Their eyes, they were just like, uh, they didn't know what to do. They were like, it looks like the votes have been counted and we want to leave the European Union. And I was like, it was the exact same reaction when Trump won. When I woke up in the next one and they were like, Trump's won back in 2016, and I was
Yeah,
like,
people
because
are melting down.
the people in the media were like, what's happening? Oh, I
Absolute
loved it. It was
meltdown.
hilarious.
So
Cool. Anyway, what I'll do like I did before. If I just sort of do me stock cam like that, and then mostly shut up, and then just chip in if I think I've got something to add. Is that okay?
yeah, no, you're totally fine to just talk. I mean, I don't have a problem with that at all, man. So you can hang out unless you,
Oh yeah, yeah. I just
you
don't want to. I mean, you'll have your thing to go through about the actual thermodynamics. I don't want to sort of change your stream entirely, but I'll jump in if I've got anything I think of is interesting to add about the actual science.
okay, yeah.
Yeah,
Uh,
I'm excited for this one.
okay, so I thought there was a fourth law of thermodynamics, but apparently there's only three. Oh, zeroth law. Okay, so um,
I only saw the three, but now you got me doubting.
zeroth law is the fourth law, but it's not called the fourth law. All right, let's say hi to everybody. What's up, Impish? I did have stuff ready to go. It's pretty impressive. Sleazy. What's up, buddy? What do you mean, cheater? Hey, Digger. Good to see ya. Linda. Hello. Greedy bloke. What's up, buddy? Dance, biker, dance. I just met him, actually. For the first time.
Yeah, I've heard he's a right jerk.
Jude, good to see ya. The mightiest of all the meats. Yes, I was late and sleazy.
I was gonna say, if you got the soundbite for that one, I don't know if you have, or if it's you know which one I mean.
Yeah. Where did it go?
Oh, and it would be amazing if you have got that Hayden clip to add to your little clips.
I know. I'm working on it. It's just a long video, so I got to process it. So.
Yeah, you got to find a bit to clip out.
Gay!
It always makes me smile every time, no matter how many times I've heard it. Same with the duck ones.
Yeah, there's some good clips that just every time. So, what's up, man, bud? You've come to learn today? Man bun said one time that she's not smart enough to makes her feel dumb or something. So we're trying to make her feel welcome.
Yeah, Mikey's just winging it anyway. He just reads stuff. He's just pretending he understands what it says.
I have no idea what's going on at all. All right, so we'll start with the book as usual. So the way that I do these, Dance, is I bought a 30-second theories book, and it has a bunch of different theories in it, and it has, a short synopsis of it. And the reason I bought it is because it gives me content forever, because there's 54 different theories in here. So I just go down the line, and gives me a year's worth of content. So, and then expound upon it, obviously. So
yeah, I remembered that wrong. I thought you said there was 52. I don't know why. My brain
there
doesn't work.
I don't know. There might be 52. Maybe there is.
Mandela effect.
I don't know. So there's a lot. Meaty's cookie is actually more of a Scooby snack. I'll break out the fancy ones for chat. Aw, I get a Scooby snack? Impish must feel bad for being mean to me yesterday. Probably not. If you want to know how heat moves around, you need to understand thermodynamics. The theory is governed by 3 laws. See, this NASA lies. The first one states that whatever is going on, the total energy in the universe stays the same. In other words, you cannot create or destroy energy. You can only change one form of energy to another. Debatable.
Just before you go on, are you supposed to be having this on screen or not?
No, I'm just reading.
Oh, okay. Yeah.
Okay. Sorry. This is like a physical book. The second law says that an isolated system entropy always increases. Entropy is a measure of the part of its energy that cannot be put to work in some way. For example, as a watch spring unwinds, it has less and less power to keep the watch running. Its entropy rises because the spring's potential energy is slowly transferred to the hands as kinetic energy, with some energy lost as heat because of friction in the mechanism. The third law states that as a system's temperature drops towards absolute zero, the lowest possible temperature, negative 459.67 degrees Fahrenheit, or negative 273.15 Celsius, which is about 2 degrees cooler than it is in Michigan right now. Ridiculous. That was a joke. It's not 459 or 457 below. All natural processes cease to occur, and the entropy reaches a minimum. The upshot of this is that it's impossible to reach absolute zero because no processes can get you there. Thermodynamics is not as abstract and esoteric as it sounds. It was developed in the 19th century by Lord Kelvin and forms the basis for your house's refrigerator and central heating, the engines that move your car, and the biological processes that keep you alive. Related theories are chaos theory, so good. That one's near the end. Important people are William Thomson and Lord Kelvin. And according to the theory of thermodynamics, a refrigerator does not add cold to your food. It takes away the heat away. It does this by compressing a fluid in the pipes on the back of the appliance. And our 3-second thrash, Lord Kelvin's brilliant description of the nature of heat shows us that nothing ever costs nothing. And our 3-minute thought to finish up. Until the second law of thermodynamics came along, many people believed it was possible to create perpetual motion. You got to take on perpetual motion, Dance?
Yeah, I've never. Whenever you see these perpetual motion machine things, I was thinking that's never going to happen. There's always going to be some resistance and friction and entropy.
Yeah, you always lose some energy. So
yeah, exactly. Yeah, even if it's just movement on a. No matter how good a bearing is, it's going to create some noise. It's going to create some heat. It's going to create yeah. It's just not gonna. It's never going to happen. You're not going to get out more than you're putting in.
Right. One example is designed to light a house without using up any energy. An electric motor turned a wheel on a generator, which provided power for lighting the house and also turning the electric motor. Although this may seem daft now, it was big business in the 19th century. Many industrialists tried to solve the problem, hoping to make an immense fortune. And we can get close to zero entropy, but it's not possible. Actually,
and if anybody actually did invent something like that, immediately all the energy companies would send people to come and do bad things to you.
Yeah,
and to steal all your technology and and hide it. Yeah,
eliminate you permanently.
Yes, and make you an unperson.
Start there.
Right. Well, in terms of the third law of thermodynamics, the sort of absolute zero, the lowest temperature thing. You know how you said you can't get there?
Yeah.
It did happen once. And it was when Jussie Smollett went and bought himself a Subway sandwich. It was
that was
cold.
very cold.
Yeah.
Very, very cold. Trying.
Did you notice as well that Man Bun said they wanted to name their son Entropy?
That's
my
awesome.
ex-husband wouldn't let me. Probably a good thing.
That's awesome. Trying to look for. Oh, here we go. So this is the common one that everybody, when we're talking about perpetual motion, and maybe we'll go into this in a minute, but this is supposedly a perpetual motion device. Spoiler alert, it's not.
Perpetual motion device. Now, perpetual motion device is actually impossible according to the first and second laws of thermodynamics, and it basically states that it is something that can make continuous energy without losing any energy forever until the end of time. Although that would be a great concept, it doesn't actually exist. But if it did exist, it would sort of look something like this. purchased this thing on Etsy. It took me a few months to arrive. I know a lot of people who've ordered some of these online and just basically got ripped out of their money. You can actually add multiple beads as long as the beads don't fall at the same time. But how bizarre is that to look at? It definitely feels unnatural. Like this video and subscribe for more cool things.
Don't like this video. Don't subscribe to this guy. And
I noticed you disliked it. I could see that on the screen.
I don't know why I'm subscribed to this guy. So this is not a true perpetual motion machine. One, you're not getting any energy out of it.
I had some thoughts immediately on this. It's stealing the energy it needs from the gravity, from the potential energy using it. So it's not. Yeah. Sorry, you go. You go.
So there is also I forget who broke it down. I think Action Lab might have. There is a electromagnet with the battery in the base, so it's feeding energy to make it accelerate.
So it can't actually have enough momentum on its own to get back up there. You mean?
Right.
I did not know that. So it's cheating immediately. It's a trick.
Well, yeah, that's the problem with it, is because they have to produce an enormous amount of energy to be able to harness any of that energy. So to be able to use it for, whatever purpose, you would have to have a pretty significant amount of energy. So if not, it would just cool. You're not using any energy, but it's not doing anything for you.
So just to clarify that thing there, if there was if it was just switched off, like you say, there was a thing underneath creating electromagnetic force and stuff. Yeah, it wouldn't have enough momentum to get back into the thing at the top, would it? Because, like you say, it's going down. You've got some energy is going by noise, some by friction, against the little metal bars. So, is that what you're saying? Is it like a trick? If it's switched off, the marble doesn't. Well, sorry, the little ball bearing doesn't make it to the top again. Is that right?
It doesn't make it to the top again after a certain. I think he got like 3 out of it, but
so many. Yeah, eventually. Because eventually it's losing, like say, from friction and noise and all that kind of stuff. Yeah.
Right. So it doesn't have the same potential when it's at the top. It doesn't move as much, and then it doesn't have enough energy to get back. So
and eventually it'll hit the side and fall off. Yeah.
Yep. So next on the docket, and excuse me 1 second, guys.
Ooh, if he's gone, I can take over and say all the naughty things. In fact, I can even get an evil voice. Let's see.
Sorry about that. I needed my heater on. It is so cold in Michigan right now.
Oh, I was just going to go evil and take over.
Zach, what's up, buddy? First law of thermodynamics. Talk about thermodynamics. I think that's Fight Club, but I like where you're going.
I like that.
I wouldn't know.
We've immediately broken the law. Actually, we haven't really delved into the first one yet. I mean, you went over the 3, but that's one of the ones that, if you don't mind me talking about it now,
go for it.
Immediately blows the Big Bang Theory out of the water for me straight away. And I know that you, from what you've told me before, you're more of a proponent of simulation theory.
Yeah, absolutely.
Anyway. But yeah, so basically the Big Bang Theory is like, oh, we'll immediately have to break the first law of thermodynamics straight away.
Right.
I'm like, yeah, I don't really quite go with it myself. I know it's the one that most people just believe is correct, but I'm not me personally. You'll know that because I've obviously got certain personal beliefs which are more religious than anything else. But scientifically as well, yeah. For me, the Big Bang Theory doesn't make any sense.
No, the Big Bang Theory makes 0 sense whatsoever. I'm not a huge proponent of it. I think it relies on a lot of assumptions that are incorrect, and unfortunately, it's one of those things that can never be tested because, as you'll know from video, we can't see that far back because it was too dense.
Yeah. I mean, CERN's having a good chance, trying to recreate things, but they're more likely to blow us all up, or rather suck us all into a black hole.
Yeah. that's for sure coming. What's up, Stevie? I hope you're doing well. Yeah. Stevie was a little tipsy last night. So. Even though he's pregnant, he's gonna end up making that baby stupid.
Yeah, I missed all this stuff because I don't know what it is. I came in halfway through the whole conversation about the pregnancy thing. Is it you or Val that's got him knocked up?
It was me. Not my proudest moment.
I think we're going to need a paternity test on this one.
He came on to me. Well, it might be Sleazy because he was giving Sleazy some love last night. So
there's two sides to every story. That's all I'm saying.
Mm-hmm. What's up, Vicky T? You haven't missed much. We've been basically hanging out. So
yeah, Mighty was late too. So you're not.
Yeah, I was
not
late
that far
too.
behind. Yeah.
What's up, X-Comer? Good to see you, buddy. What did you say? Believe in? You only heard of creation or evolution. That's because you don't watch enough of my videos, dear. I believe in simulation theory. Did I do a video on that?
I think you touched on it on other videos, but I don't think you've done an explicit, like one exclusively about it, dedicated to it. I don't think that I remember. But then my memory's terrible, so you could have done it like 3 days ago, and I still would have forgotten.
Mine's terrible as well. That's why I'm looking back through dead internet.
Entropy is definitely happening with my body.
Yeah. Very quickly, very, very quickly, with me. No, it does. I mean, it's not looking like well, let's see.
I think you're actually younger than me, though. You haven't got any excuses. You're a young whippersnapper, I think.
Yeah, not at heart. Like I feel 90.
You're an old man stuck in a young man's body.
Yeah, absolutely. No, I apparently I did not do one. I'll have to do one specifically on sim theory.
Yeah, that'd be good. Yeah. I'm a ginger man trapped in a ginger man's body. It works out fairly well.
No, it apparently, man, but I didn't unless you. So, Digger, I apologize for shaming you publicly because it doesn't look like I did one. Can I search my own videos? I know that sounds stupid, but
I mean, I know you've mentioned it, and
yeah, absolutely, I've mentioned it.
Yeah, I just don't think it was a dedicated video about it. I think it was just in other videos. This is what my memory's telling me. In other videos, you'd sort of said about how you were sort of more for the simulation theory rather than the standard thing that people go by.
Oh no, I did. It was it's probably my least viewed video. That's probably why. 1 month ago, I did a simulation theory talk.
I'll have to go back and watch that.
I can throw the link in chat so you guys can see it. That's what I believe in. A perpetually motionless machine.
But yeah, so yeah, that's the first one. The oh, sorry, hang on.
No, Impish is just talking crap. So go ahead. Sorry.
Yeah, no, just the first law of thermodynamics kind of like obviously puts a doubt straight away on the Big Bang theory, but then also the entropy, the second one, also for me puts doubt on the theory that after it had rained for 2 million years on the rock and there was a primordial soup, that then just these complex chemical things started happening and creating things that, particularly DNA type stuff, which actually water destroys. All of a sudden, it's going to start doing the opposite of what entropy usually causes to happen. It's another one that, for me, that just doesn't make any sense. And I just want to let people know as well, I'm a bit of an odd one because like I grew up in a family where my dad's kind of an atheist. My mum doesn't really know what she believes. So I haven't had any religion put on me at all. I grew up and I was taught all the science stuff, evolution, that the world is millions of years old, all this kind of stuff. That's what I believed, because that's what I was taught. And it's only the more research I've done and as life has gone on and experiences I've had, I now believe completely different things. Which is, I guess, unusual, because most people maybe come from a religious background and people say, oh, that's just because that's what you've been brainwashed into believing and stuff. But I'm like, no, I look at the science and think this sounds like nonsense. The Big Bang and evolution to me doesn't fit at all. And yeah, I don't want to go off on a rant, because there's a whole load of things. I'll probably make a series of videos, stuff to do with the soft tissue found in the dinosaur fossils, the vertical trees and going through multiple layers, which there's loads of things, population numbers, sea salt levels. There's a whole host of things as to why I think that what we get taught in schools is basically not probably what happened at all. And I know you've got your different take on it, which is the simulation theory, which I find fascinating as well. But
yeah, I think it's, well, so I was on with Steve Gosney last night, and I think everybody has a different experience, and it's fantastic. We got into talking about this part of it. It's always great to listen to other people, because other people have different thoughts, feelings, ways of dealing with stuff. And I think it's really imperative that we listen to each other, learn somebody's story. It makes a huge difference. So,
yeah, I don't know much about Gosney's. Was that on one of your streams with him? Because I could maybe try and catch up with that. Was he talking about his background a bit?
No. So he major boomer. Love him, but major boomer. What's up, Mystic? And what's up, Belandris? But we were on his first ever live stream last night, and it was Rumble. He's only on Rumble.
Excellent.
Yeah. So
cool.
He had us on because I was helping him a lot behind the scenes, get everything set up and teaching him how to do stuff. What's up, Crystal?
Yeah, so the blind leading the blind, and no, I'm just kidding. the boomers leading the boomers.
All right, job.
But yeah, because I think from what I've heard, he does his guitar stuff and that in videos on Rumble, but I don't think he'd ever done live streams before, so he needed you to help him with that, didn't he?
Yeah, it was a mess. So it took us 6 attempts for him to figure it out by himself. So, but we got it eventually.
That's some good boomering. By the way, Digger 420 is backing me up here. Yes, Digger, I agree. I could probably make some videos about some of that stuff at some point. Carbon dating, might be one of the first ones I do about. Yeah. But anyway, that's a different subject. But it kind of leads into the thermodynamics, because for me, the thermodynamics brings up all these questions about what the accepted theories are. Big Bang and all that kind of stuff.
Right.
Yeah, and also because I forget what they call this, but you know how the current model is, when the Big Bang first happened, and very shortly into it, split second into it, then the rapid expansion then accelerated out of nowhere, and they give it the name. Is it either dark flow or dark energy? I forget which one for that.
Dark energy.
Dark energy. Yeah. So again, whenever there's something that they don't really understand, they just throw the word dark in there.
Right.
So yeah, because whenever you got an explosion like a grenade or something, it goes at its fastest and then it slows down. It doesn't go pretty fast and then suddenly rapidly accelerate.
Right.
Without there being an extra force on it. So yeah, sorry, I keep going into a rant. I'm sorry. But I think out loud. But yeah, I just wonder what your thoughts on that were, because I know you weren't a fan of dark matter. So have you got the same thing where you think dark energy is a bit of a cop out as well?
Yeah. So I think that they just add dark to anything to answer questions that they either don't know the answer to or need to get their theory across the line. And I think that's cheap, and I'm not a fan at all. I think it's just a way to, oh yeah, it fits because I made up this dark energy. I don't know that it even exists. So something exists. We're missing something, but that's where simulation theory comes in. So we're not meant to have it all. At least that's my thought.
Purposefully kept in the dark.
Right. Crystal, yeah, hopefully this is a good way for you to get away from that case. That case is it is dragging so much. Have you been watching any of Vice's or Ricada on the case about the guy in South Carolina that killed his wife and kid?
Allegedly.
Allegedly.
No, I've seen it. I haven't followed that one. When Crystal said that the case is slowing down, I thought she meant the case for the Big Bang Theory.
No.
But yeah, no, yeah. I heard that they're charging the guy, even though is this the one where there's still no body, there's still no evidence, it's all circumstantial stuff. Is that the one?
Well, no. So they found both the bodies. Both the bodies were there.
Oh,
but
okay. Oh no, there's some. I don't know. Yeah, it's something about the 2 different firearms used. Is it that one?
Yeah. And his family ran this town for 102 years or something. Like, it should be so exciting, but they've.
I would have preferred the dumpster defenders, but that one wasn't allowed.
Yeah.
By the way, I think we're getting told off by my countryman, greedy bloke. I think said, "Can we decide on a topic?" Sorry, that's probably my fault for derailing it. But at least the stuff about Big Bang Theory, evolution, alternative theories, that was at least linked to the laws of thermodynamics.
You people, like, I'm having a conversation with a really good guy, and we're talking around the topic. So, So anyways, I wanted to make you guys aware of this. If you get a chance, look up at the skies tonight. The green comet, it has a green tail, and it's supposed to be pretty spectacular. See 2022 E3 ZTF. This is February 1st, but tonight is going to be probably your best viewing angle. You could probably maybe see it tomorrow as well. It was supposed to be visible for a longer time, but it dove into the sun, and we didn't think it was going to make it out. 50,000 years, once every 50,000 years, you can see this elusive green comet. So only Dance will be alive for the next one and was alive for the previous one.
I'm not that old. But yeah, no, I'm glad you mentioned it again, because that's what I was actually talking about on my stream yesterday. It was only like a 15-minute stream, and then I realized you were on, so I finished up. But I was looking through, and I thought, oh, I better go and try and see if I can see that one. So hopefully, if it's not cloudy over here, I'll try and go out tonight. I think it's just north of where you've got like the Big Dipper, the pan bit of it, not the handle bit, leading up above that. I think it's north of that is where to look. I've got some binoculars and stuff. I'm going to go out, because I've only once in my life managed to catch, I told you this before, managed to catch one and actually see a comet. Because there was a few, was it a couple of years ago? There was all the Swan and Atlas ones. There was a few. And every time they were going to be visible, and it was only for a brief window of time before the sunrise of where I lived. And it was like cloudy every time. And I was like, really? Because I had to drive out. There's only about 5 minutes from where I live, but there's like where the coast is, where there's less light pollution and stuff, where there's right where the sea is. And I was going out at like 4 or 5 in the morning. But it was worth it. I eventually saw one with my own eyes, and it was an amazing thing to see with your own eyes.
It's fantastic to be able to see with your own eyes. I did the same thing with this one. Where? Hang on. I gotta find it.
Crystal, yeah. The live solar eclipse is, again, if you ever get a chance, absolutely amazing. So good. I'm glad you got to see one. I was lucky in the 90s. There was one that went across Cornwall, right at the bottom of the country, and we went down for that on Newquay Beach in Cornwall. We managed to see the full solar eclipse. I think I was only about 13 or something. No, how old was I? I don't know. I can't remember. But it was in mid sort of 90s, and yeah, if you ever get a chance to see one, and then Americans, you'll get a chance to see one. When is it now? 2024, I think. Yeah, I think 2024. There's another one going over the US, over the States.
What are you talking about? So this
Oh, we're
is
talking about.
Oh.
Oh no, we were talking about not comets. We were talking about solar eclipses there.
Oh, gotcha. So it's really hard to photograph a comet if you've ever tried. So this is Neowise. A couple of years ago, stood out in the field for days, all night, trying to take photos of it. So, and it was cloudy that day, but I still got a chance to see it. So there's the comet.
That's
tail.
cool. That your photo, really, yeah?
Yeah. Yep.
Nice.
I took that. So
Neowise rings a bell. It might have been Neowise that I managed to see, because there was Atlas that broke up. There was Swan. I know they're named after like the places that sort of discover them.
Yeah.
So you get like several Atlases and several Swans and stuff. But
Mm-hmm.
Neowise rings a bell. I wonder if that's the one I saw.
It was, I want to say it was like 4 years ago. I'll Be Dead by 2024. The movie was Maximum Overdrive. Huh? You people.
That's a bit cryptic, Jude. What? I would like to think that you won't be dead by 2024. I'd like to think you'll have a long life.
That would suck.
Do you know, dying, that's going to be the last thing that I'm going to do.
Yeah.
Tumbleweed there.
It's Oh, Xcomer, thanks for the Rumble rant, buddy. I appreciate that. For science. Gotta love the science. Well, we're gonna get into the science finally. We're to the article point. Maybe.
Yeah, we'll get to the science if I shut up and let you get to the science.
Yeah.
I think that's a good plan.
If I kick dance from the stream, then we can get to the science.
I was going to say put a poll. No, don't put a poll. That'll be yeeted. I'll be yeeted from the stream immediately.
So I can't talk about rocket engines, so we're going to talk about jet engines instead. It's not the same thing. Thermodynamics is a branch of physics that deals with the relationships between heat and other forms of energy. In particular, it describes how thermal energy is converted to and from other forms of energy and how thermal energies affect matter. Thermal energy is a substance or system has due to its temperature. In other words, the energy of moving or vibrating molecules. According to the University of Kentucky, thermodynamics involves measuring this energy, which can be exceedingly complicated. David McKee, a professor for physics at Missouri Southern State University, told Live Science, the systems that we study in thermodynamics consist of very large numbers of atoms or molecules interacting in complicated ways. But if these systems meet the right criteria, which we call equilibrium, they can be described with a very small number of measurements or numbers. Often, this is idealized as the mass of the system, the pressure of the system, and the volume of the system, or some other equivalent set of numbers. So what's that saying is vibration and friction between particles. So I don't know if you guys know. So if you have something that's very hot, you'll have particles very close packed and they're moving around like they're jiggling all over.
Yeah, this is why microwaves work. They actually vibrate the water molecules very quickly to create the heat. So if you put something dry in a microwave, it won't warm up, but something wet will, because it's the movement, isn't it? That's creating the heat.
Yeah, of
vibrations.
Course. Yeah. And then the flip side to that is if you have molecules that are very cold, they are spread out and they are nearly stopped. Like it's like a continuum. So the hottest temperature until it changes state, they'll be closely packed together and vibrating. When they get further or closer to that 0 Kelvin or absolute zero, they actually stop moving completely. So they get further away stop moving. So, yes. Thermodynamics then is concerned with several properties of matter. Foremost among these is heat. Heat is the energy transferred between substances or systems due to temperature difference between them. According to GSU, as a form of energy, heat is conserved. It cannot be created or destroyed. It can, however, be transferred from one place to another. Heat can also be converted to and from other forms of energy. For example, a steam turbine can convert heat to kinetic energy to run a generator that converts kinetic energy to electric energy. A light bulb can convert this electrical energy to electromagnetic radiation, which, when absorbed by the surface, is converted back into heat. Though this process, a portion of the energy is lost to entropy. So this is specifically talking about phase changes. So if you don't know, and they're pretty easy to make, you can make one with magnets and copper wire. Maybe I can do that at some point. But so if you turn copper through a magnetic field, it induces electromagnetic force and creates energy. Changes energy. Creates electricity. So that's how they build turbines to produce energy. I think so, especially in the nuclear context, I think we should just harness energy from the actual reaction instead of using it to heat water to turn steam turbines. But nobody wants to listen to me because I'm not a nuclear physicist. So
might be one of those that's good in theory but doesn't work in practice, or would just blow up in practice. Maybe, I don't know. Or maybe they should listen to Mighty.
They probably should. That's always the best idea. So yeah, when you're talking about something like heat, obviously you're burning a fossil fuel, or if ghosts are real, i.e. spirits, please explain ghost clothes. Never understood that. 1, ghosts are not real, and 2, they would not be wearing clothes. That doesn't make any sense. Conversion, conduction, and evaporation. As the nurse, we learned about how patient loses heat. Yeah, that's the same general practice. So one of the things that changes is volume. So obviously, we're talking, the volume doesn't actually change, but the space that it takes up, like the actual amount of water doesn't change, but the space it takes up, or the volume, actually does. So here you have the frozen ice, so it's compacted. Here you have the melted water, and then here you're introducing did I do that backwards at the beginning, Tance?
I don't think so. You started with the ice and moved. You started with ice and moved along.
Yeah. Okay.
Yeah.
So you're introducing air and heat bubbles, so it's increasing the volume that it takes up. The amount of heat transferred by a substance depends on the speed and number of atoms or molecules of the substance in motion, according to GSU. The faster atoms or molecules move, the higher the temperature, and the more atoms or molecules that are in motion, the greater quantity of heat they transfer. No, so I was right. Temperature is a measure of the average kinetic energy of particles in a sample of matter, expressed in terms of units or degrees designated on a standard scale. They put so many citations in this paper. The most commonly used temperature scale is Celsius, which is based, communist, they mean, which is based on the freezing and boiling points of water, assigning respective values of 0°C and 100°C. The Fahrenheit scale is also based on freezing and boiling points of water. It should be the Freedom scale, which have assigned values of 32 degrees Fahrenheit and 212 degrees Fahrenheit, respectively.
I love the way you just have to complicate everything. How is this so simple? 0 degrees freezing point, 100 degrees boiling point. Yep, for water, and you've got 32 and 212. Brilliant. That's way to complicate things. Amazing.
Makes sense to me. Exactly. Just for that, I'm gonna come haunt your ass.
Something that just on that subject, because I don't want it to be wars between the British and the Americans. I like you guys, but you know how you did that thing for Hayden, that video where you're sort of talking about the land of the free and all that kind of stuff.
Yeah.
I was gonna do a parody of it, but with like the British, but just be like that, like we are the ones who drink tea and all this kind of stuff. And
You should have.
I know, but it would have been a lot of effort. So I'm lazy. I'm lazy, but if I had time, if I had the ultimate time and didn't have a job to do and stuff, then yeah, I would have made that for a laugh.
That would have been awesome. Yeah, that was a good video. I like that one. So it's just energy. Energy is naked, no clothing. Exactly. Scientists worldwide, however, use the Kelvin, K with no degree sign, because they have to be difficult. Scale named after William Thomson, first Baron Kelvin, because it's based on the total thermal energy rather than the freezing and boil points of water. According to, I'm just going to stop reading citations. This scale uses the same increments as the Celsius scale. For example, a temperature change of 1 C is equal to 1 Kelvin. However, the Kelvin scale starts at absolute zero, the temperature at which there's a total absence of energy, and all molecular motion stops. A temperature of 0 Kelvin is equal to minus 459.67 Fahrenheit or minus 273.15 Kami units.
Yeah, and so that's the third law of thermodynamics, isn't it?
Oh. There we go. To my idea. It's still not commercially viable. Well, it could be.
There we go. So according to ChatGPT, oh yeah, XCOM uses the AI chat thing, doesn't he?
Oh, he loves that thing.
So you're right. This is like I was saying. It's one of those things that sounds good in theory, but they haven't got the practice sorted out yet. So they're still not quite got that sorted out. But I understand the premise completely, because the more things you add into the equation of your nuclear reaction to then heat the water to make the steam to the turbines, you're going to lose energy along the way at each extra stage you put in there. Which is why, which is why, say the vehicle engines are not terribly efficient. They, but they're just great fun. So I'd still prefer, me personally, I'd prefer a petrol motorbike engine over an electric one, even though the electric one would be more efficient in terms of turning energy straight into torque. It's just it's not as fun. But again, I'm derailing my own thought process. But so I can get I see your point as to why with the nuclear energy creating electricity, it would be beneficial to try and go straight from the reaction to the electricity production without having all those extra steps. We just don't know how to do it. I guess we should ask that GP bot thing. Maybe that'll know how to do it.
Well, again, nobody's asked me.
XCOM, get onto that. Instead of asking it things that just like, I don't know, like to create e-girls or something, ask it how to create new inventions, and hopefully ChatGPT will help create useful things. Maybe.
Yeah. So the amount of heat required to increase the temperature of a certain mass of substance by a certain amount is called specific heat or specific heat capacity. According to the conventional unit for this is calories per gram per Kelvin. The calorie is defined as the amount of heat energy required to raise the temperature of 1 gram of water at 4 C by 1 degree. Anybody lost yet? Yes, Stirling engines are really cool, Andrews. Specific heat of metal depends almost entirely on the number of atoms in a sample and the way they bond, not the sample's mass. For instance, a kilo of aluminum can absorb about 7 times more heat than a kilo of lead. A given mass of water, however, can absorb nearly 5 times as much heat as an equal mass of aluminum, thanks to the strong forces binding water molecules. So it depends on a molecular level. That's why some things act different than you would think. So thermoconductivity is the rate at which heat passes through a certain cross-section of a specific material. Jeez, that's such a long citation. The unit for K is watts per meter per Kelvin. Values for K metals such as copper and silver are relatively high at 380 and 420 W/M times K, or 2K, respectively. This property makes these materials more useful in automobile radiators and cooling fins for computer chips because they can carry heat away quickly and exchange it with the environment. So that's why you have aluminum fins on, different cooling systems, like they said. The highest value for K of any natural substance is diamond at 2200. So quite a bit more, 5 times more, 5 times more than silver. So according to a 2009 study published in the journal Materials. Other materials are useful because they are extremely poor conductors of heat. This property is referred to as thermal resistance, or R value, or resistance, which describes the rate at which heat is transmitted to the material. These materials, such as fiberglass, goose down, and styrofoam, are used in installation, exterior building walls, winter coats, and thermal coffee mugs. R is the given value of units of square feet times degree Fahrenheit times hours per thermal unit, according to, I'm trying to stop muting that.
Yeah, you missed out the word British there. Not impressed. I'm only kidding.
Was that intentional?
But just before you go past that bit, because obviously we're talking about the things that have the heat resistance the most.
Yeah.
I was thinking, because let's go into a subject that you like. Do you know what do they use then for the outside of the space shuttle and that kind of stuff? Because I guess they'd be looking for the ones with that lowest value where it's obviously they can't do it with diamond, but well, I suppose it could. It would be really expensive. But
NASA has the budget.
That's true. Yeah.
So it's a proprietary blend. I've actually held one of the heat shield tiles, and they're unbelievable. I can actually look up what it's made of. I don't know. They are great, though. You can put a blowtorch on top of them, hold the bottom, and it's fine.
I remember at college we had these sort of ceramic tile things which we used to use for the Bunsen burners to go on.
Yeah,
they were pretty good, but
yeah, that's close. To the same thing. They're made of what's called porous silicon material that is light and extremely heat resistant. They feel really, really light, and yeah, SpaceX is using on their Starship. They're using similar tiles. They can withstand temperatures up to 2,300 degrees Fahrenheit. So they're very high temperature. They're very, very light, which is important for space travel. And they block almost all of the heat of coming through. What's up, Beaver? Over on Rumble.
See, chat, I've managed to derail him. It's really easy, actually. I just realized if I get him talking about anything to do with space travel, shuttles, rockets,
it's all over. Yeah,
then it's done. Sorry.
Yeah.
Somebody's going to shout at us in a minute to focus. Thermodynamics.
What's that in Celsius? I think it was 1260. So 12 something. 12 around there.
Anything 100 plus is going to hurt, so it all just becomes the same to me at a certain point. And it's damn hot.
So this is about heat transfer. So you obviously have, so when we're talking about a stove, it's really more complex than we give it credit for. So you have the heat. So you're burning a chemical or a fossil fuel or, a natural gas, something like that. You're getting heat energy to heat the pan. You're also getting thermal radiation. You're also getting light energy because it's releasing light. Obviously, we can see it. And then in the pan, you have convection. So you have the natural cycle of warm air rises or warm substance rises, cold sinks. So you have this constant circling of, so the cold's going down, getting heated, and goes back up. Cold's going down, getting heated, comes back up. This is similar to what's going on in our sun, convection. It takes a very long time for the light energy to escape the sun because of the convection of the sun. So
you realize though that this image is already illegal now. AOC says so.
Yeah, she became
It's a
second
gas
most.
stove, so yeah.
Yeah, she
This
became
is
the second
basically
most
some kind of
powerful
crime.
person today in the Democrats.
She what? Oh,
She,
oh, okay. I didn't know that.
yeah, there was some release that she took some office and blah blah blah. Who cares? I don't want to waste any time on her. Technologies. Yeah. You could theoretically, you would have, well, if you kept it. We're not getting into that. And then you have conduction, where obviously the heat is running up through here, up through the handle, and conducting. Also in the pan, it's conducting heat. Heat can be transferred from one body to another between the body and the environment by 3 different means: conduction, convection, and radiation. Conduction is the transfer of energy through a solid material. Conduction between bodies occurs when they're in direct contact, and molecules transfer their energy across the interface. Starlight. I have heard of starlight. It's concrete that they use for launch pads. Or are you talking about there's 2 different types of starlight. So one is a insulation material, and then the other is a concrete that is used for launch pads. I've touched it. Yeah, definitely wood chips. Like, let's not get nuked.
If you've touched it, there's going to be a Me Too coming at some point.
Right.
The way you touch it.
Convection is the transfer of heat from to or from a fluid medium. Molecules in gas or liquid contact with a solid body transmit or absorb heat to or from that body, and then move away, allowing other molecules of the fluid to move into place and then repeat the process. Yep.
Yeah, so basically if you put your hand on the side of the pan that's on the pan full of water, or if you got a kettle boiling, put your hand on the side, then you'll know what convection is all about, because it'll hurt.
Yeah. Radiation is the immersion of energy via EM radiation, particularly infrared photons that carry energy. All matter emits and absorbs from EM radiation, the net amount of which determines whether this causes a loss or gain in heat. So, for example, the radiation, electromagnetic radiation coming off my space heater that's at my feet feels very good right now, and it's giving me a gain in heat because I'm losing a lot of it because it's freezing. I'm gonna skip Carnot's cycle. We'll talk about 4 laws. We'll talk about this and then the laws and blah blah blah. Then we'll see. Yes, exactly, Greedy. You're getting it. It's not terribly expensive either. I mean, I think it was like 4 times more expensive than normal concrete. But the problem is it's relatively weak, but we're not talking about that. All thermodynamic systems generate waste heat. The waste heat results in an increase in entropy, which is a measure of disorder of a system. Because work comes from ordered molecular motion, entropy is measured of the energy that's not available to do work, according to Britannica. God, I read another citation. Entropy is a closed system, always increases and never decreases. Additionally, moving parts produce waste heat due to friction, and radiative heat inevitably leaks from the system. I know, but I'm talking about a specific star. There's a star like concrete as well. I know that I know you're talking about something different. I'm stuck on the concrete because I know what it is, particularly. This makes so-called perpetual motion machines impossible. Saibal Mitra, a professor of physics at Missouri State University, you cannot build an engine that is 100% efficient, which means you cannot build a perpetual motion machine. However, there are a lot of folks out there who still don't believe it. And there are people who are still trying to build perpetual motion machines. Waste of time. You can get to like 99.9% efficiency, but just like speed of light, we can't ever get there.
No! Stay with me!
Sorry about that.
What?
I was just messing with the soundboard. I was trying to find one that said like "stay on target" or "focus" or something. But...
I need
one
of those.
And I think I was muted when when it said that some people were still trying to build the perpetual motion machines. I pressed this one.
That's stupid.
I don't think it came through because I was muted at the time. So.
Wait, what?
I'm focusing, Digger. It's his fault. Entropy is also defined as a measure of the disorder of randomness in a closed system, which inexorably increases. You can You can mix hot and cold water, but because a large cup of warm water is more disordered than 2 smaller cups containing hot and cold water, you can never separate it back into hot and cold without adding energy. Put another way, you can't unscramble an egg or remove cream from your coffee. Entropy therefore provides us with an arrow of time. Forward is the direction of increasing entropy. So, Some people think that you should be able to return things to their original state, and they don't understand that you lose different physical characteristics. And even if you could reverse the phase change or the change in, say, scrambling and cooking an egg, you would have less egg on the other side. So yeah,
I've got an audio an audio representation of entropy. Yeah, that works too. Yeah, so this is what I was saying earlier about the whole theory of where life came from.
Yeah,
it doesn't seem to fit with entropy, with that second law of thermodynamics.
Yeah, absolutely, and we'll talk about that real quick after I finish these, because chat will yell.
Gotcha, bitch.
And we worry about washing our hands. What? The fundamental principles of thermodynamics were originally expressed in 3 laws. Later, scientists figured out that Moore's fundamental law had been neglected, apparently because it had seemed so obvious that it did not need to be stated explicitly. To form a complete set of rules, scientists decided This most fundamental law needed to be included. The problem, though, was the first 3 laws had already been established and were well known by their assigned numbers. When faced with the prospect of renumbering the existing laws, which would cause considerable confusion, or placing the preeminent law at the end of the list, would make no logical sense. Ralph Fowler came up with an alternative that solved the dilemma. He called the new law zeroth law. Here are the 4 laws in brief. So there are 4 laws, so suck it.
It was the prequel, so they added it later but called it the zeroth. And
Right.
It was, a prequel law, effectively.
So the zeroth law states that 2 bodies are in thermal equilibrium with some third body, then they are also in equilibrium with each other. So that seems... This establishes temperature as a fundamental and measurable property of matter.
Wait, no, this just sounds like the scientist was trying to figure out a way of getting himself a threesome.
Well, yeah, exactly. Like,
he was trying to sort of justify it there somehow, by the sounds of it, using it as a chat-up line in a science convention.
I mean, absolutely a base scientist, because most of them are nerds, and I can say that because I know a lot of them, and they're nerds. What's up, Val? The first law of thermodynamics states that the total increase in energy of a system is equal to the increase of thermal energy plus the work done on the system. This states that the heat is a form of energy and therefore subject to the principle of conservation. But that is, it can be neither created nor destroyed. So that, yeah.
So that was what you were saying. That whole list that you went through was all the different ways in which the energy can sort of change from one form to another and move across things. But yeah, it's just all sort of reinforces the first law of thermodynamics. So it's never being created or destroyed. It's just changing from one form to another. And
right.
There was a whole list of different things you showed, like the stove and all that kind of stuff, as to how it can do that.
Right.
Some of it changes to light, some of it changes to heat. Yeah, all that kind of stuff. Yeah.
Yeah, and you have radiation, and there's phase changes. What's up, Jacob? So there's different phase changes, and it really makes a difference with it's almost impossible to measure, and I think they made note of that in here. But there is no loss of energy, just change. So all the energy that exists on the planet, in the solar system, in the universe, is already here. It's just in different forms. So makes sense? Yeah. Okay. The second law of thermodynamics states that heat energy cannot be transferred from a body at a lower temperature to a body at a higher temperature without the addition of energy. This is why it costs money to run an air conditioner. So heat can't be transferred. So you can't remove, and the air conditioner is probably the best. I'm probably going to murder this one, but if something is 10 degrees, I can't remove 8 of those degrees if what I'm trying to remove it with is 60 degrees. Yeah, I just mucked it up. Question: could thought be considered as having matter?
Well, it depends how you look at it. If thought is electrical messages going across the brain, firing across around the brain, so there's electrical energy is part of the thought. So the thought is electrical energy. So I guess it has. Well, would you consider electrical energy to be matter? It's using matter, but it's not matter itself.
I think it's using matter as a bridge. As far as we're talking with thermodynamics specifically, yeah, you're getting energy, you're getting electromagnetic energy. So, and that causes heat. So, I think it absolutely adheres to these principles, but I don't think it's specifically matter. It's using matter and photons and light energy and stuff doesn't have any mass or matter to it. That's why they're so damn interesting. Photons are very interesting. But I guess the atomic structure, so if you're, and I don't know that much, I'm not a biologist, so I can't tell you if it's a woman, but Vegas 2007. What? Anyways, just kidding. So I don't actually know if the electrical impulses use, because they're not going through a copper conductor, so I wouldn't think that they're electrons, but I don't know. Which are maybe.
Wait a second. So, obviously the electrical stuff that's going along in the brain, in the nervous system, those electrical, do we not know if that's actual electrons then or not? Is that still unknown?
Well, it's still unknown to me because I don't do biology at all. It's just not my thing.
So that means you don't know what a woman is.
Exactly. Yeah.
Yep.
I have no idea. That's
Same.
what I said. Vegas 2007. I made the wrong answer.
The little anecdote. Actually, there was a lad I used to work with called Stu, and he said he went over to like Thailand or whatever, and picked up this girl at a disco. went back to his hotel, and he said that where he was there at the time, the locals actually have to show their sort of like ID, passport type of thing at the hotel if they're going in with like a foreigner sort of thing. So he's going into his room, and then he's starting, and the person shows a bit like a driving license type ID, whatever it is, and then the person at the checkout, not the checkout. Why can't I word today? Why can't I speak? You know what I mean? The entrance to the hotel. They said to Stu, "You know this is boy. you know this is boy," and he had no idea. So he just laughed. He just laughed and then went off to his room and left the person there. That's the story he tells, but whether he actually took the person up to his room, I don't know.
Well, yeah. I got a story for night show at some point, but.
Oh, sorry, I forget it's today's show for you guys. Oh, sorry.
I'll
write that in.
I try to keep it wholesome. My chat screws it all up, so I don't care.
Yeah, I blame the chat too. Yeah. Not naughty chat making me say that story.
Yep, absolutely. Chemical electrical, says Jacob Castro. If it's chemical electrical, then it's absolutely 100% matter. Hooking a car battery up to a corpse makes it move, though. Xcomer, how do you know that?
Sounds like
but it would stimulate muscles.
I'm worried about Xcomer now. So that sounds like the voice of experience there.
It's okay. Chat GPT told him to do it. So.
Oh, Mystic's right. Yeah. I don't blame chat. I blame you. Maybe it's you. Somehow it's your fault. Yeah. Good call, Mystic. Good call.
Yeah, they absolutely can. So, and I knew there was energy. I just didn't know if that was a photon energy or if it was a chemical energy. And if it's chemical, then it has matter. And it's also subject to laws of thermodynamics. So we got one more law. Let's get through it. Yes, very good question. I like the ones that make you think for a minute. The third law of thermodynamics states that the entropy of a perfect crystal, that is, a substance made up of atoms arranged in a perfectly ordered symmetrical pattern at absolute zero, is zero. As explained above, entropy is sometimes called waste energy or the energy that's unable to do work. And since there's no heat energy whatsoever at absolute zero, there can be no waste energy. Entropy can also be measured of the disorder in a system, and while perfect crystal is defined by perfectly ordered, any positive value of temperature means there's motion within the crystal, which causes disorder. For these reasons, there can be no physical system with lower entropy, so entropy always has a positive value. The science of thermodynamics has been developed over the centuries, and its principles apply to nearly every device ever invented. Its importance in modern technology cannot be overstated. And there's, crystals. Well, nuclear crystal energy batteries are what will solve our energy crisis for damn near forever. So I agree. Where was I at? Where was I at, Dance?
Well, just going on to that third one. So it's basically the absolute zero, isn't it? Where there is no entropy because it's all stopped. There's no energy. Yeah,
Right.
like you say, it's never actually been. It's one of these theory ones, isn't it? Because there's no place that I'm aware of in space or in the universe where there are these conditions.
Right.
I don't know what the coldest temperature we can detect in space is, but it's not as cold as this, is it? This. Am I right in that saying that?
Yeah, because there's always interaction with particles, so there's always friction, there's always heat, and there's always chaos and disorder.
And radiation from stars and all that kind of stuff.
Right, exactly. So, and people think that science is Apostle Steve. Yes, but not today. Oh my God, they're so incredible.
The solid, what have I heard about? See, I should know this. I picked up on some of this when I used to work at the lithium-ion battery plant for Nissan. Some people were talking about stuff and about like the new generation would be, is it where it's more, instead of like a liquid electrolyte, there's more like a solid one that's made of a certain, I don't know if it's crystal, but anyway, I'm sorry, mumbling and thinking out loud again.
So you're part of Big Battery. So.
I'm what, sorry?
You're part of Big Battery.
Oh no, I was. No, I was. Yeah, for about 4 years, I worked at we made the Nissan Leaf battery packs, the lithium-ion batteries. Yeah, so it was quite a big factory. There was, I think we were the only one in the UK of that size at the time. But it was the whole process from getting raw materials through into the clean room, through then the sort of, you make the cells, you inject the electrolyte, and they sort of do the gas process. You get that out of it, and age it through all the different heat things and stuff to make sure it doesn't, to make sure it's safe, all the way through to being the modules, and then into the battery packs themselves and all that, out the door and into the cars across the road. It was quite an interesting place to work for a bit.
That's cool. Huh.
Hard work though. It's a young man's game, man. My body's wrecked.
How new is quartz? So I don't know. These ones particularly use diamonds. There's some that use quartz. Maybe I'll go into this on how it works Thursday. So I'll do Thursday at noon, Stevie. How new is quartz? I don't know. Again, not my field. Do you know?
Me, no idea. This sounds like a really interesting concept, though, using nuclear waste to, just convert directly into electricity for batteries. Yeah, that'd be cool.
And they're saying that your cellular phone would outlast the components, so you could get 50 years off a single charge, or without changing size much. So you would never have to charge it again. So energy is still working on tissue that has ceased cellular function, dead. It uses energy for decay and decomposition. Absolutely, it does. 100%, Jude. It uses all kinds of energy, chemical processes. It just doesn't have the body still works. Works is a strong statement. The body still carries out processes. It just doesn't have the consciousness anymore after you're dead. But for some people, it didn't have the consciousness while they were alive. So.
Yeah, it's like I heard this thing once. It said, was it what happens? What happens after you die? well, a great many things happen. It just you won't be involved in them. That's all.
Right. You just checked out. So
Yeah.
No,
But I know what you mean. You're saying about the body, obviously the materials in the body, and they start to break down the cells, and the things happen at cellular level as it decomposes. So there's all some manner of energy transferences going on. Yeah,
for sure.
There's still a lot of chemical substance and energy in the flesh of the body and all that kind of stuff.
Right, and decay and all that good stuff. So yeah, there's all kind of processes, and you're even more desirable to certain things. That's why things eat you and break you down. So, so that's about where we're about 22 minutes longer than I like to do, and that's all Dance's fault.
That's my fault entirely. Yep.
So, but I appreciate everybody stopping by. Dance, you want to show for a minute? You want to sell yourself?
Yeah. Hi. Yeah, just I don't know. Just thanks again for having me on. I always enjoy the talks, particularly when it's about scientific subjects. Like I say, eventually in time, I would maybe do a mini series of different things where my take is different to the scientific consensus. You know, stuff to do with, like, say, carbon-14 dating and all that kind of stuff. And you can feel free to obviously rip me a new one and tell me I'm wrong and and do a rebuttal on it all. But no, I just find these interesting subjects. And who was it that came up with that really interesting question about the about whether the thought is matter and stuff? That was great.
Jude.
Right, yeah. So props to Jude for that one. So I'm like you. I like those kind of things where it makes you stop and think.
Right.
Yeah, I'm not sure. Right. Yeah, more research needed and stuff. But yeah, no, I hope that I might add something to these streams rather than getting in the way. I know I derail you a little bit, but that's all part of the fun.
I appreciate having you to talk to. You're a smart guy, and I appreciate it. So next week we have, and I threw his link in there. Give him a sub if you haven't already. For nothing else than us going back and forth. I haven't disagreed with you terribly.
Yeah, no, I mean, there's going to be some stuff where we have different takes on stuff, but like, I think there's a lot of stuff we probably would see eye to eye on, political stuff and all sorts of things, and just having a laugh. And, you know,
I mean, I haven't called you stupid yet. I'm not like stupid ass and just like end the video. Maybe I'll do that next time. But.
Yeah, which is odd because everybody else does, my wife and my kids. You may as well throw one in there. They think I'm an idiot. But yeah, I'll have to try and check out. Did you say it was you and Val were on Gosney's Rumble thing?
Yeah, we were on last night. So
yeah, I'll try and catch up with that. So
yeah.
And hi to Val, by the way, because we never really sort of seemed to actually end up on at the same time much. He did jump on one of my streams once for about 5 minutes, which was great, and I'm glad all the goats are starting to come out. So that's cool.
Yeah, I was concerned that they didn't exist, but you know, they're here now.
Eventually. And a big congratulations to Jessica Reloaded for getting monetization. So that's really cool.
Yeah. Hung out
Yeah.
over there last night, played some Phasmophobia for a minute. But
oh yeah, I think when I woke up this morning, you guys were just finishing up because I couldn't figure out what the game was, and I was like, "Are you going around Epstein's Island or something?" Or are you? And then I was like, "Oh no, hang on, what was it?" Yeah, no, I forget. I was saying all this manner of inappropriate comments, so they weren't bringing those up. I was being a bit degenerate. It was like some kind of ghost hunter game or something. Is that right?
Yeah. You have to determine what kind of ghost it is. It's like a mystery game where you have to do certain things and find out what type of ghost it was. So
I figured it out eventually, but to start with, I had no idea what was going on.
I usually get killed. I don't think I died last night though. Maybe once, but yeah, I usually die. So for next week, oh, sorry, you got some.
Well, I was just gonna say I'll jump out now. It's not long until I take my daughter off to soccer anyway. So thanks again for having me on, and yeah, we'll talk again some other time.
All right, buddy. Thanks for joining me. Have a good one, man.
All right, take care, everyone. Bye.
And that was Dance Baker Dance Phasmophobia. Yes, Wild Red. We've been playing that a little bit. So after Gauze. Yeah, it's snowing. I won't see it either. You might still be able to see it. So take a look. Maybe I'll make a post and try and hit a picture of it. So next week on Science Thursday, we discuss electromagnetism. It's one of my favorite ones. So that will be a heated discussion. And then we get into the direct theory of relativity and why I disagree. So those are the next two coming up. I'll do those nuclear batteries because people seem to be interested in them, and I think they're impactful. But that is it for today. Get back to that terrible trial over on Vices or Rikita, and everybody have a great day. I will be on Jessica Reloaded's Am I the Asshole tonight? So no show here on Mighty Meat. But if you still want to hang out, I'll be over there. And that's about all I have coming up. So thank you, everybody, and everybody have a great day. Take care.